All right, 9.2, triangle congruent postulates and theorems. Students will be able to use the congruent postulates and theorems to determine whether triangles are congruent. So basically what we're going to say here is there are a few different ways to determine whether triangles are congruent or not. I'll go over them in this video, and we have names for them. And so the first one, and the most common one, is the side-side-side postulate. We call it SSS. And that says that if there are three sides of one triangle that are congruent to three sides of another triangle, then the two triangles are congruent. I just like to use a little symbol here. You could write out the whole word, but I'll probably just use the symbol for congruent. All right. Again, just what does congruent mean? It means that the exact same size and shape. So we see these two triangles here. They're exactly the same size and shape. And we know that because this side and this side match, this side and this side match, this side and this side match. So triangle bow is congruent to triangle man. All right. That's not the only way, though. We have another way. We also have side angle side. So this one says if two sides, and the connecting angle of one triangle are congruent. What do I mean by connecting angle? So here are these two sides and the angle that connects them. Two sides, and the connecting angle of another triangle, then the two triangles are congruent. All right, what are we saying? We're saying that if you got two sides that match up and the angles in between match up, then these whole triangles have to be congruent. So in this one, we see this side matches with this side matches with this side, and then these angles are marked that they're the same, they're congruent, so therefore these whole triangles have to be congruent to each other. So we could say the triangle ABC is congruent to triangle DEF. So let's take a look at this. Let's put some of this into practice. Oh, but before I do that real quick, I just want to point out something. So a postulate, which is the word they're using here, a postulate is just something that we can assume to be true. And on the next page, a theorem is something that is proven to be true. So postulate is something we could just like kind of assume, like it's almost like obvious, but a theorem, that's something that we can prove it to be true. All right, let's take a look at these again now. So what I want to do on these ones, all they really want us to do is tell you how we know they're congruent. But I want to spend a little bit more time on each of these to show you kind of what you're going to be doing in this chapter. Because you're really going to be, the idea here is that we want to be able to prove something. We want to prove something very, very well. And ask me in class to talk about Abraham Lincoln and proofs. But to do that, we want to be able to list out everything we know. And so what we could do is we could say, you know what, what's the first thing I know? Well, the first thing I recognize here is that NY, segment NY, is congruent to segment PY. And how do I know that? Well, it's marked right here. So anytime it's marked, I would say that's given. And so what I'm going to do is I'm going to list some statements, and I'm going to list the reason I know those things to be true. And this is what a proof, it's called a two-column proof, but this is what a proof generally looks like. I'm going to list things over here that I know to be true, and over here I'm going to write how I know they're true. Okay, so what I just did is I said, I know these two things are the same. And so essentially I have a side and a side here. What else do I know? Well, I also know that this side and this side are the same. So I'm going to write that, my next step. I'm going to say that NQ is congruent to PQ. How do I know that? Well, it's marked in my drawing. They told me so. So I'm going to also say given. All right. But that's only two sides. And we know so far we need at least two sides and an angle, or all three sides. So what else do I have? Well, this is where you're going to have to kind of look at the picture and see if there's anything else that you can infer or anything else that you can conclude. And if you draw a line right at the center here, you might be able to say, you know what, I think that this line segment, YQ, is congruent to itself. And you would be right to assume so. Seems super obvious, but yeah, it's going to be congruent to itself. So we could kind of, I like to do a little like X mark on that, say it's congruent to itself. And so the last statement here is, we could say that YQ is congruent to YQ. I'm going to highlight that. Now, oh, I wanted to mark these as well. So remember, I also have that these sides are the same, and obviously I just marked that these sides in the middle are the same. That's what I'm trying to get to. I'm trying to find 3 sides on this triangle and 3 sides on this triangle, so I could say that these triangles are congruent by side, side, side. All right, if I can use side, 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 I know they're congruent. But I need a reason for this one, okay? I need a reason. And I know the obvious, what you might want to say is, oh, they're just congruent to themselves. Yeah, that doesn't really suffice in a proof. We need a reason. And there is basically a rule that says just that says, hey, these things are congruent to themselves. And it's called the reflexive property of congruence. And what that basically says is, hey, if you reflect this line over itself, it's still congruent. That's kind of all we're saying, right? That the YQ is a reflection of itself, and therefore it's congruent to its own reflection, or it's congruent to itself. All right, at the end of the day now, my 4th statement is going to be that I know that triangle NYQ is congruent to triangle PYQ. Now, the order that I just wrote this matters. So I did NYQ. So everything has to match. So since I did NYQ, I have to label it PYQ. If I said that NYQ is congruent to QYP, that would be wrong, because what I'm saying then is that angle N matches with Q. So these should all line up. So like angle N and P match up. Obviously angle Y matches up, and angle Q match up. And what's my reasoning for that? Well, I'm going to use the side, side, side postulate. And there I have just proven that these 2 triangles are congruent. Okay. Let's take a look at B. I think you guys could actually do this one if you wanted to do a whole proof. But I don't think we really need to do that on this one. I just wanted to kind of show you an example of a proof over here. So let's just talk about what do we have here. Well, obviously we could see that this side and this side are both 5, therefore they are equal to each other. We can see that this side and this side are both 4, therefore they're equal or congruent to each other. And then obviously these angles are both 100 degrees, so therefore they're congruent to each other. So what does that give me? Well, in this first triangle, that gives me a side, an angle, and a side. And in this triangle, that gives me a side, an angle, and a side. So we could say, at the end of the day, in my proof, it would say something like triangle RQS is congruent to triangle VTS, and we would say by SAS. All right, let's take a look at this one. All right, this one, I want you guys to try to do this as a proof. I'm going to start you off. You always want to start with what you just, like what you know, what's given, what's easy. Okay, and this is a very common type of problem to see as a proof. So what do I know? Well, I know that DC is congruent to BC. Again, pay attention to that order. It matters, right? You might want to say DC is congruent to CB, and that's true, but we want to, in general, keep things that correspond in the same spot. So D goes with B just as C goes with C. And how do I know that? Well, that's given. What's the second thing that I know? Well, I know that AC is congruent to EC, and that's also given. But that's all they really give you. So you have a side and a side, a side and a side. What else do you know? Okay, well, I'm going to help you with this, and I'm going to see if you can remember the Y. But the next thing that you're going to say is you're going to say that angle ACB is congruent to angle ECD. And again, pay attention to that order. I did A first, so I did E first because they correspond. Good practice to have. All right, but how do we know that, folks? How do we know that this angle here is congruent to this angle here? That's essentially what I'm saying. I'm saying this angle and this angle. How do I know that? Well, I want to let you try to figure that out and then complete this proof, okay? And the last thing you're going to do, the last step in this proof, is to actually say, well, triangle ACB is congruent to triangle ECD. And hopefully you can see how you would know that, because you have two sides here, and I'm asking you to establish that these two angles are congruent. So I want you to see if you can finish this proof all on your own. What would be the reason for this, and what would be the reason for this? And then unpause the video and check your work in just a second. All right, well, hopefully you recognize that these are called vertical angles, and we learned earlier that vertical angles are always congruent. And what that does is that gives you an angle in between on both of these, and so you can see side angle side, side angle side. You can establish that these two triangles are congruent by side angle side. All right, let's go to the next page. All right, got a couple more. We got this one. It's called angle side angle, or ASA, and this says if two angles and the connecting side of one triangle are congruent to two angles and the connecting side of another triangle, then the two triangles are, you guessed it, congruent. Okay, what does this look like? See, I have an angle here, I have an angle here, I have an angle here, I have an angle here. These angles match up, and these angles match up, and the side in between matches up. And so what do we have? We have angle, side, angle, angle, side, angle. Again, I got to go in order around the triangle. I couldn't have an angle here, a side here, and then an angle. That wouldn't work. I'd have to go. If that was the case, well, that's actually what's going to be the next one. So you got to go in order. But if I had an angle here and an angle here and a side here, that'd be angle, angle, side, which is what this one is. So we got to go in order of how we see that around the triangle. So that's angle, side, angle. Two angles and a side. That's all it really is. It's got to be either marked, or we got to be able to infer it. But we'll see some more examples of that in a second. All right, the other one here is the angle side, or AAS theorem. And this says if two angles and a corresponding side of one triangle are congruent to two angles and the corresponding side of another. There's a blank here, and there really shouldn't have been, so just ignore that. So the corresponding side of another triangle, then the triangles are congruent. Okay, what does that look like? So now we have two angles that match, and we're talking about a third side over here. It could be here and here, that's fine. But we have two angles and then a side, two angles and then a side. And you can kind of see it as you go around. Angle, angle, side, angle, angle, side. And so now at this point you might be thinking like, okay, there's so many, like what doesn't work, right? So we have, so far, what do we have? We have SSS, that works. We have side, angle, side, that works. We have angle, side, angle, that works. And we have angle, angle, side, that works. So there's four. And you might think, well, just does any combination work? And the answer is no. So these are all good. I'm going to put like a green check mark above this. These are all good, okay? There is one combination that we have not done so far. Actually, there's two. There's two that do not work, okay? These are two that do not work. The first is AAA. That does not work. Because if all the angles are the same, let me show you. If all the angles are the same, that doesn't mean they're congruent, right? So like I could draw a triangle like this, and I could draw another triangle with all the same angles, but you could see like the angles could match up. My drawing's not that great. But the angles could match up, but these triangles are different sizes, so they're not congruent. So AAA doesn't work. And the other combination of letters here that doesn't work is SSA. And you could use your imagination as to what that spells backwards. We generally put it as SSA. This doesn't work, side-side angle. We like to say there's no donkey theorem in geometry to help you remember. So these are two combinations that do not work. These are all do, these do not. All right. let's put this into practice again. Let's take a look at, again, they want us to figure out what theorem or postulate, like how do we know these things are congruent? So let's take a look at example 2a here. And I think that you guys are catching on with what we can do here. If I'm not going to do the whole proofs again, we'll do more of that later, but what do we know? Let's take a look. Well, we know obviously that this side and this side are the same. So I'm going to write that I have a side. We know that this angle and this angle are both 90. Then what else do I know? And what you're supposed to recognize is, again, we have these vertical angles, therefore they must be the same. And so we can mark them as the same, and then we would say that I have an angle and an angle. And what is that? That's angle, side, angle. Right, angle, side, angle, I have it in both, so we're good. All right, let's go on to the next one. What about this one? Okay, so clearly we have these angles marked in blue, we have these angles marked in red, but we don't have anything else, do we? Well, remember, we have the reflexive property. The reflexive property says that this side right here is congruent to itself. And so we do have a side. That's an ugly S. Let's try that again. A side and a side. So what do I have? I have angle, angle, side, angle, angle, side. So now you might be tempted to say, well, can't I just say SAA? There's not really a good reason other than it's just not how we call it. So just know when we can do alphabetical, we do. That's generally how we do it. But the order and how we go around the triangle is the main thing that we're focused on here, right? Like I couldn't start with this angle, do this side, and then skip an angle, skip a side, and call this ASA. That wouldn't work. It's got to be fluid. I could skip one side or one angle, but I can't skip both when naming it. So this is angle, angle, side. All right, what do we got here? Well, we got a lot of information here, actually. So based on just what's marked, right off the bat, I could tell that I have an angle, a side, and an angle, and an angle. So that would be angle, side, angle. However, we also have vertical angles here, so we have a third angle. So we could also do angle, angle, side if I went this way. Right? Or I could do angle, angle, side this way. So there's actually 3 ways to prove that these two triangles are congruent. And I say proof, right? If I was to actually prove it, you'd have to do like a 2-column like I showed you earlier, where you lay out how you know everything. And here, almost everything would be given, except for here you'd say you know these because they're vertical. Again, remember here, we would know this line segment is congruent to itself. We'd say RS is congruent to RS because of the reflexive property. And here we would say we know these angles are congruent because vertical angles are always congruent. All right, so I know I don't normally have you do the summary, but I do want to point something out to you. It says this, name the 5 ways to prove triangles congruent. Well, I only gave you 4, and there are 5. There is a 4th way, and it's a special way. It only works for right triangles. So I know I don't usually have the summary, but I'm going to show you one more thing here. And this is called HL theorem. And it only works in right triangles. Okay? So you're going to have to just bear with me with my bad drawing here. So what this one says is if you have a right triangle, and HL stands for the hypotenuse, oops, wrong tool, and the leg. And that just says if you have a hypotenuse that's congruent in 2 triangles and a leg that's congruent in 2 triangles, as long as they're both right triangles, then this would be enough to prove the triangles are congruent. Again, this only works for right triangles. And if you look at it, look, this is an angle, side, side, ASS. You might think like, oh, this is the one you said doesn't work. Well, it's because the donkey theorem really isn't a thing because it only works for right triangles. And so we need to be very specific in this situation. It's only going to work for right triangles. So at the end of the day, the 5 things you have, again, are SSS, SAS, angle, angle, side, angle, side, angle, and then you also have this HL. Those are your 5 ways to prove triangles are congruent. All right, we're going to play with that more in class. I'll see you guys next time.